Hello, my friends. We are going to talk in this video about sequences and series, specifically algebraic sequences and word problems. So you know how much I love algebra, so mixing sequences and series with algebra is just like amazing. So here we go. So this is a super cool way. I think it's super cool. You're probably not. But this is a super cool way to look at sequences is through algebra, meaning that the terms contain x. So instead of the terms being numbers, 3, 4, 5, 6, the terms contain x. So let's just dive into two examples, a geometric and an arithmetic. So let's look at arithmetic first. So here is a sequence. Now notice this sequence is algebraic, right? It's 3x minus 1, 5x plus 5. So instead of my first term being a nice number, my first term is 3x minus 1. My second term is 5x plus 5. My third term is 7x plus 11, right? Okay, so listen, it's algebraic, right? So who cares? Listen, if a little birdie sat on my shoulder and whispered into my ear, x equals 3. Well, then I could actually go ahead and find this sequence quite easily. Just plug in 3 for all the x's. 3 times 3 is 9. 9 minus 1 is 8. 3 times 5 is 15. 15 plus 5 is 20. 3 times 7 is 21. 21 plus 11 is 12. Or not 12. Sorry. 32. 9 times 3 is 27. 27 plus 17 is 44. Now, if I were to look at it this way, you'd say, oh, that's arithmetic. Up 12, up 12, up 12. How easy is that? But listen, no little birdie sat on my shoulder, so I don't know that x equals 3. So this is what I got to deal with. So listen, I could still talk about this being an arithmetic sequence. But the question is, what am I going up by? Well, just look, right? Well, we're going to show you two ways to do this, but one is just look, right? From the first term to the second term, I increased by 2 x's. I went from 3x to 5x. And from -1 to 5, I added 6. And again, that's the same thing. If I'm looking for the second to the third term, once again, I increased 2 x's. 5x to 7x is an increase of 2x. 5 to 11 is an increase of 6. And then going from the third to the fourth term, 7x to 9x is an increase of 2x. 11 to 17 is an increase of 6. So again, my common difference, what I'm going up by every single term, is not just a single number. It is an algebraic expression, 2x plus 6. Now, if you're looking for one more way that you could find that common difference, just subtract any two common terms. Remember, it's called a common difference for a reason. If you subtract any two consecutive terms, you get that difference. So if I take 7x plus 11 and subtract 5x plus 5, well, that's going to get me 2x, 7x minus 5x. 11 minus 5 is 6. Boom, there's the 2x plus 6. Okay, so that's my common difference. Now, what else do I need for the formula? Now, hold on, let's slow down here. Remember, the formula for an arithmetic sequence is very easy. It's simply the first term plus that common difference times n minus 1. All right, so I just got to find that. So I already found my common difference. It would be nice if it was a number, but hey, this is algebra. Now, what's my first term? Well, you guessed it, 3x minus 1. Duh, it's the first term. So all I got to do is fill in the blanks. So the first term is 3x minus 1 plus, now I got to put this in parentheses because the common difference is not a single number. It's an expression, 2x plus 6 times n minus 1. So there it is. Now listen, I could go ahead and do some distribution back here if I wanted to. I could certainly clean this up. Let's go ahead and do that. 3x minus 1 plus, okay, so I get 2xn. On the inside, I get a 6n. And on the outside, I get a negative 2x. And lastly, I get a negative 6. So if I combine all my like terms here, let's see, I get a 3x and a negative 2x. So that's just x. Then I got a 2xn. And then I got a 6n. And then again, the negative 6 and the negative 1 are also like terms. It'll make a negative 7. So again, at this point, I honestly don't care. Like, I would not mind if you left it looking just like this. That is a formula to find any term you want. But you could also go ahead and do all the multiplication and combining like terms. And you could clean it up a little bit, even though, again. So now you understand is x is a number, but n is my term value. N is my term value. So if I want to find the 18th term, I'm turning the N into an 18. So that's going to be x plus 2x times 18 plus 6 times 18 minus 7. So let's see, that's x plus, 18 times 2x. That's going to be 36x. 6 times 18 is 108 minus 7. And again, combining the like terms there, I get 37x. 108 minus 7 is 101. So the 18th term, if I continue the pattern of add 2x plus 6, add 2x plus 6, add 2x plus 6, the 18th term is 37x plus 101. So again, it's just throwing algebra into the mix. That just means there's going to be an x there, an unknown. But when you do the formula, n still represents the term you're looking for. All right, let's do another example, but this time it's geometric. I'm multiplying this time. So I'm going from the first term to the second term to the third term. And the question is, what am I multiplying by? So real quick, what is the formula for the nth term of a geometric sequence? Well, it's the first term times the common ratio to the n minus 1. So what's my first term? Well, 3x squared. All right, what's my common ratio? What am I multiplying by? To go from one term to the next, what am I multiplying by? Well, it looks like I'm timesing by 4. 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. And then it looks like I'm multiplying by x cubed. If I take x squared, multiply by x cubed, I get x to the 5th. Another x cubed, x to the 8th. Another x cubed, x to the 11th. Now, if you're looking for another way to figure out that my common ratio is 4x cubed, just divide any two consecutive terms. So if I take 12x to the 5th, that's the second term, divided by 3x squared, that's the first term. Divide those, you get 4x to the third. Bingo. There's your common ratio that goes inside the parentheses here. Now, I would encourage you to not do anything with this. Please do not multiply 3 times 4 and say 12. You cannot multiply because, again, order of operations, the exponent's first. And this back part here is the exponential part, and it says 4x cubed, but it's not 4x cubed. It's 4x cubed raised to the n minus 1. So please don't distribute. I would just leave the answer like that. So how do you find the 8th term? Well, again, n is the term number. So if I want to find the 8th term, I'm just going to plug in 8 for the n. Again, my answer is going to have an x in it still. So I have 3x squared, 4x cubed, raised to the 7th. Again, 8 minus 1 is 7. Now I can clean this up because 4x cubed to the 7th is going to be 4 to the 7th, x to the 21st. And then let's see here, 4 to the 7th is, big number, 16,384 times x to the 23rd. Now, I got one more little thing to do. I forgot the 3 is still sitting here, right? So 4 to the 7th was the 16,384. X to the 21st and x to the squared is a total of 23 x's, so x to the 23rd. So the only thing left for me to do is multiply the 4 to the 7th, the 16,384, multiply that by 3. So I get a final answer of 49152 x to the 23rd. So if I keep multiplying by 4x cubed, multiply by 4x cubed, multiply by 4x cubed, multiply by 4x cubed, the 8th term of that sequence will end up being 49,152 x to the 23rd. All right, not too bad. Again, I love algebra, so I love throwing a little bit of algebra into these problems. It just makes you think a little bit more. But again, I'm still following all the rules. It's not that difficult. All right, so this was covering algebraic sequences. Be ready for the next video to talk about word problems.